Okay, now I'm looking at number 10 from section 3.3, and it says solve this equation, and I've rewritten the equation over here so you can see it better. 3x to the third minus 26x squared plus 33x plus 14. Okay, well so far the only way we know how to solve polynomial equations is you set it equal to 0 and factor completely. Well, this has 4 terms and I can't factor by grouping, so I'm not sure how to factor. So in this section they're going to give us a hint. So let's go back and read the problem. And the hint is solve this equation given that 2 is a 0 of this polynomial function. Now what does that mean? We're going to reproduce our list that we had in class on the board in a moment. But for now, if I tell you something is a 0, so if I tell you that 2 is a 0, it means that 2 is an x-intercept. And it also means that the factor x minus 2 is a factor of this polynomial. So I can start factoring this polynomial by saying, well, it's x minus 2 times something. How do I figure out what that something is? I use division. You can use long division or you can use synthetic division. I'm going to use synthetic division on this lovely little piece of paper below. Now be careful. Synthetic division, I put positive 2 in my little box. And then I list my coefficients, 3, negative 26, 33, and 14. Let's make my line. 3, 6, negative 20, negative 40, negative 7, negative 14, 0. Okay, now, we knew we were supposed to get 0, right? Because if something's a factor, or a 0, that means that when you plug that x value in, you get 0 for a remainder, okay? Alrighty, or 0 for an answer. That's what it means to be a 0, literally. So now I transfer these, remember these first 3 numbers here, give us the coefficient on the factor that's left. Now since I've already factored this, it started as a 3rd degree polynomial. I've already factored an x minus 2 out of it. Well, they told me that. And so therefore what's left is a 2nd degree polynomial. It starts with 3x squared minus 20x minus 7. Now once you get down to a 2nd degree polynomial, you have 2 choices. Choice 1 is, can you factor that? Sometimes you can, but sometimes you can't, which takes you to choice 2, which is use the quadratic formula. This one you can factor it. Okay, so let's put down our 2 parentheses. And I can tell you can factor it because I multiply the 3 times the 7 and I get, actually I even take the negative, I get negative 21. And I go, could I combine, is there some way to get negative 20 out of things that add up to negative 21? Sure. Okay, how about 1 and 20? Okay, so let's do that. So let's see. I think I said that wrong, but you guys know what I mean, right? Sorry. So I have 3 here, 3x times x, and then I want my 7 here to get my 21. And then I want my 1 there, and I got to decide what's positive and what's negative. The 7's negative, the 1's positive. Double check by foiling it out. And now we get our 3 zeros, which I'm going to list over here because I've, of course, run out of room. Let's put them in our nice set brackets. They already told me that 2 was a 0, or a solution to the equation. Negative 1/3 will be a solution to that equation, and positive 7 would be a solution to that equation. Okay, number 11 is the same type of problem, only this time the way they're giving us the hint is they're showing us the graph, or part of the graph of this polynomial. Again, they want us to solve this equation by factoring completely, and they tell us this time that x equals negative 2 is an x-intercept. But I know if it's an x-intercept, that means it's a 0 of the polynomial. And if it's a 0 of the polynomial, I know that x plus 2 is a factor of the polynomial. So I can start factoring right away, and I know that x plus 2 is one of the factors. How do I figure out what's left? I use division to find out what's left. Okay? So I'm going to pause and do that to the side while you guys do it at the same time, and then I'll come back with the answer. Okay, so I went off to my scratch paper and I did my synthetic division, and I figured out that if I factor out x plus 2, what I'm left with, the quotient I'm left with, is x squared plus 7x plus 12. And can we factor that? Oh yeah, that's a nice easy one to factor. That would be x plus 3 times x plus 4 equals 0. And therefore, my three solutions to this equation are -2, -3, and -4. And one of the reasons we would want to find all three solutions to that equation is so that we could finish graphing this polynomial. They showed part of the graph, but we could do the whole graph now that we know all three x-intercepts. Okay, that's section 3.3. So I'll start a new video with some information for 3.4. Hello class. I want to start section 3.4 with this list of statements that are equivalent. They also they come from part of what we learned in section 3.3, and then we learn a little bit more in section 3.4. And remember, part of our goal with these two sections is to be able to factor any polynomial completely, or if you can't factor it, then find a way to find all the zeros of it. Okay? So this is Renee's version of a bunch of different things that are in theorems and definitions and whatever that are in the book. So these statements are equivalent. Equivalent means if one of them's true, all of them are true. That's what equivalent means. So it's a little formal. Given a polynomial function, we'll call him f of x, and a constant, we'll call it c. It's any number. The following are equivalent. That means once you know one, you know them all. Okay? First, x equals c is a 0 of f of x. Now, they did that to us in 3.3. They told us what a 0 was. Remember, sometimes zeros are called roots, okay, of a function. The second thing is, if it's a 0, that means x minus c is a solution to the equation f of x equals c. Now, that's fancy for take your polynomial, set it equal to 0. That number, c, is one of the answers. It's one of the solutions. Well, if we're graphing and I take a function and set it equal to 0, what do I find? Those x's are x-intercepts, which brings us to the next one. X equals c is an x-intercept on the graph of that function. And that's important because we are graphing polynomials in this chapter, so we have to find ways to find all the x-intercepts. Okay? Number 4, that also means that x minus c is a factor of f of x. It's one of its factors. I can start factoring this polynomial. And last but certainly not least, when dividing f of x by x minus c, by the factor of x minus c, the remainder is 0. That's what it means to be a factor, that the remainder will be 0. So please copy these 5 equivalent things down and keep them handy because we're going to need them in 3.4.